We're going to start section 9.2. It's titled The Binomial Theorem. And in a quick nutshell, what we're going to be learning to do is to be able to expand a binomial to any power. We're going to see some really cool patterns that exist here. So we're going to be able to, when we get done with this, be able to expand any binomial to basically any power. You might think, like, for example, okay, if I had a plus b to the third power even, well, how would you approach that? Well, most of you would probably say, okay, I'm going to take a plus b, and a plus b, or some of you might say, oh, I'm going to take a plus b squared times a plus b, and hopefully all of you know the pattern for a plus b squared is just a squared plus 2ab plus b squared. I know, however, having taught this class for a long time, some of you would foil this and say a squared plus, ab and ab is 2ab plus b squared, and then you're going to take that times a plus b. So either way, you're going to end up with this trinomial times this binomial, and you're going to have to take this, a squared times a squared times b, 2ab times a, etc., and take everything in here times everything in here, and you're going to come up with an answer. But what we're going to learn is there's a pattern to this. You're going to learn that you're going to know that, and you probably already memorized this one, the a plus b squared is a squared plus 2ab plus b squared. And when you get done with this, you're going to know that a cubed, and by the way, the coefficients here are 1, 2, and 1. And the coefficients here are 1, and this is going to be 3, and this is going to be 3, and this is going to be 1. And here it's going to be 1, and then it's going to be 4, and then it's going to be 6, and then it's going to be 4, and then it's going to be 1. And we can continue, I can continue to do this, and I'm going to a little later, go all the way down. I can do a plus b to the 9th, a plus b to the 10th, and I can rattle this off. There's a way that you're going to learn to figure out what these numbers are without having to do all of this work. There's also a nice pattern to the letters and their exponents. You notice that this went a squared, then a to the first, and then no a at all. In other words, a to the 0. And the b's are no b at all. In other words, b to the 0, which is 1, and then b to the first, and then b to the second. So the a's started at a squared and went down by 1 each time until it got to a to the 0, and the b started at b to the 0 and went up by 1 each time until it got to b squared. Same thing all the way down here at a to the 4th. It goes a to the 4th, a to the 3rd, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and then a to the 0. The b's go b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th. So that's what we're going to be doing. That's just a little quick intro there. And now we're going to get to where you can start taking your notes. So as I just got done talking, now we see the same thing, but I start out here, a plus b to the 0. Well, a plus b to the 0 is 1. A plus b to the first is going to be simply, it's 1a plus 1b. All right, and then a plus b squared is, as we did earlier, it's 1a squared plus 2ab plus b squared. A plus b cubed is a cubed, 3a squared b plus 3ab squared plus 1b cubed. A to the 0 is 1. They in this example, they put the a to the 0s in and the b to the 0s in. So in a plus b to the 4th, it's 1a to the 4th plus 4a cubed b to the 1st plus 6a squared b squared plus 4ab cubed plus b to the 4th. All right, so a couple things I want you to observe about this expansion. First of all, I want you to take a look at the exponents. I want you to look at the coefficients. A plus b to the 0 has simply 1. The coefficients for a plus b are 1 and 1. The coefficients for a plus b squared are 1, 2, and 1. For a plus b to the third, it's 1, 3, 3, and 1. And for a plus b to the fourth, it's 1, 4, 6, 4, and 1. And so how does this continue on? Well, I'll show you in a second. There's a pattern here. And this, by the way, is called Pascal's triangle. Okay? Pascal's triangle. And I want you to notice a little pattern here. I want you to notice that here we have a 1 and a 1, and I want you to know in the next row down, there's a 2 right here. Well, 1 plus 1 is 2. I want you to notice here's a 1 and 2, and look at the number down here in between it. In the next row down, it's 3, because 2 plus 1 is 3. 2 plus 1 is 3. Going down to this row, we have 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Notice that we start and end always with a 1. Okay? So that means that hopefully you would be able to get the next row, which is going to be a 1, and then 4 plus 1 is 5. 6 plus 4 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. And that's a 1. And these are going to be the coefficients for a plus b to the fifth. All right? And then after that, I'm sure you would guess that this in here, this would be a 1, 6, 15, 20, 15, 6, and 1. And we'll take a look at that later. So let's go ahead and these are going to be the coefficients. And we'll talk more about this in a minute. Let's take a look at some observations. In each expansion, there are how many terms? Well, when it's to the 0 power, there's 1 term. When it's to the first power, there were 2 terms. When it's to the second power, there are 3 terms. So I'm going to conclude that there are n plus 1 terms for a plus b to the n. The powers of a will decrease by 1. We already talked about that. And the powers of b will increase by 1 each time. Now we'll look at the sum of the powers of each term. So we'll look at this term right here for a plus b to the fourth. The powers that are on the variables a and b are 4 and 0. The sum is 4. The powers on the a and b here are 3 and 1. The sum is 4. 2 and 2, the sum is 4. 1 and 3, the sum is 4. 0 and 4, the sum is 4. So it looks like, and if you go back to the one that's cubed, the sum of the powers is 3. Each and every single term, the powers add up to 3. In the one that's squared, the sum of the powers, all the powers add up to 2. And each term has the sum of the powers being 2. So the sum of the powers is always going to be whatever degree or power that you're raising the binomial to. So the sum of the powers of each term will be n. So now, for binomial coefficients, the binomial coefficients that appear in the expansion of a plus b to the n are the values of, and this is where we need to take a look at what those are. And this is going to be quite amazing to you. So here we see Pascal's triangle again. You can see it goes all the way down to where we would be expanding a plus b to the sixth. These are the numbers for the coefficients for a plus b to the sixth, but you can see Pascal's triangle here. If we were to continue on, the next row would be 1, and then 6 plus 1 is 7, 15 and 6 is 21, 20 and 15 is 35, and then another 35, and then another 21, and then a 7 and a 1. You might notice, and I didn't mention this before, that this is symmetrical. We have 1 on each end. We have then 7s, and then 21s, and then 35s in the middle. And that's when you are raising it to an odd power. You notice that it was when it's raised to the 7th power, there are 1, 2, 3, 4, 5, 6, 7, 8 terms. We already said that it was n plus 1. So when you have raised to an odd power, there's going to be two numbers in the middle that are the same. But when you're raising to an even power, that's going to give you, in this case, it's a plus b to the 6th. There's 7 terms, which gives you a middle term of 20 by itself. And then on each side, 15 on each side, 6 then after that on each side, and then 1s on each side, and bookends. So it is symmetrical where you have the same thing on both sides. Now, here's the amazing part. This number up here, 1, is the combination of 0 things taken 0 at a time. If you actually figured out the combination of 0 things taken 0 at a time, by the definition, it would be 0 factorial over 0 minus 0 factorial over 0 factorial, or I'm sorry, times 0 factorial. So basically, we know 0 factorial is 1, so that's 1. And if you take a look at the 1 and the 1, well, that's the combination of one thing taken 0 at a time, and the same thing as combination of one thing taken 1 at a time. And if you went through that process, this would work out to be both of them 1. And for the 1, 2, and the 1 is the combination of two things taken 0 at a time. The 2 is the combination of two things taken 1 at a time. And 1 is the combination of two things taken 2 at a time. Go down to the next row. This 1 is the combination of 3 things taken 0 at a time. If you did the combination of 3 things taken 1 at a time, you would get 3. Combination of 3 things taken 2 at a time, you get 3. Combination of 3 things taken 3 at a time, you get 1. Down in the next row, combination of 4 things 0 at a time is 1. Combination of 4 things 1 at a time is 4. Combination of 4 things taken 2 at a time is 6. Combination of 4 things taken 3 at a time is 4. Combination of 4 things taken 4 at a time is 1 right here. Down here, I actually worked it out, if you don't believe me, where I actually did the rule for the combination of n things taken r at a time. And you know, for example, 4 things taken 2 at a time is 4, or 1 at a time. Let's do that one. 4 things taken 1 at a time is 4 factorial over 4 minus 1 factorial times 1 factorial. And when you work it all out, you get 4. And for 4 things taken 2 at a time, it's 4 factorial over 4 minus 2 factorial times 2 factorial. And if you work that all out, it comes out to be 6. And so it is pretty darn amazing that these numbers in Pascal's triangle actually work out to the combination of n things r at a time in this wonderful pattern. So that means the binomial coefficients that appear in the expansion of a plus b to the n are the values of the combination of n things taken r at a time for r equals 0, 1, 2, 3, all the way to n. The notation for the number of combinations of n things taken r at a time, NCR, is another different notation is this parentheses with the n over the r. That means the number of combinations of n things taken r at a time. These mean the same thing. Both notations can be read n, the number of combinations of n choose r. You do need to say the word combination in there. They didn't mention that there. So now we want to expand x plus y to the 8th. How do we do that? Well, we're going to use what we just learned. So we'll start with the first coefficient is going to be the combination of 8 things taken 0 at a time, which we know is 1, but I'm going to just show you this. We'll do this on this first line. And then it'll be x to the 8th and y to the 0. Then it's going to be the combination of 8 things taken 1 at a time, x to the 7th, y to the 1st. Then the combination of 8 things 2 at a time, x to the 6th, y to the 2nd. Then the combination of 8 things taken 3 at a time, x to the 5th, y to the 3rd. Combination of 8 things taken 4 at a time, x to the 4th, y to the 4th. And I know I'm halfway now because the exponents are the same. And when it's an even power, you will always get the exponents to be the same in the middle. If it's an odd power, it would be like x to the fifth, y to the fourth, and then x to the fourth, y to the fifth. It's always one apart. But next, we're going to get a combination of 8 things taken 5 at a time, and that is going to be x to the third, y to the fifth. Combination of 8 things 6 at a time, x to the second, y to the sixth. 8 things 7 at a time, x to the first, y to the seventh. And finally, the combination of 8 things 8 at a time, x to the 0, y to the 8th. Now I want to show you how to figure out these combinations pretty quickly. We know that the combination of any number taken 0 at a time, that's always going to equal 1. And the combination of 8 things taken 1 at a time is going to be 8, whatever that first number is. And that's because it's 8 factorial over 8 minus 1, which is 7 factorial times 1 factorial. And that just, of course, is just going to be 8 because the 8 factorial, 7 factorial, everything's going to cancel except for the 8. So when we get to 8 things taken 2 at a time, it's 8 factorial over 8 minus 2, which is 6 factorial, 2 factorial. So you notice that the bottom numbers always add up to the top number. And here's the interesting thing. I might have mentioned it one time before, but I need to show it again so you can see it. The 8, 7, and of course the 6, 5, 4, 3, 2, 1 is going to cancel with the 6 factorial on the bottom. And so that's 6 factorial and that cancel, and you're left with 2 factorial. Well, that equals 8 times 7 over 2 times 1. So basically, it's going to be 8 times 7 is 56 divided by 2 is 28. The next one is 8 factorial. 8 minus 3 is 5 factorial, 3 factorial. So that's going to be 8, 7, 6. The 5 factorials are going to cancel, and you're left with 3, 2, 1. So what you're noticing is, whatever that second number is, that's how many numbers are going to be on the bottom, and that's how many numbers are going to be at the top. The top ones count down, 8, 7, 6, and you really could have written this as 8, 7, 6 over 1, 2, 3, which I kind of like. 3 times 2 is 6, they cancel. And you're left with 8 times 7 is 56. And then the next one is 8 factorial over 8 minus 4 is 4 factorial, 4 factorial. So that's going to be 8, 7, 6, 5 because there's going to be 4 numbers. The 4 factorials are going to cancel, and you're left on the bottom with 4, 3, 2, 1, or 1, 2, 3, 4 if you want to count the other way. And of course, 4 times 2 is 8. 3 goes into 6 twice. 5 times 2 is 10 times 7 is 70. So that's a quick way to find that. And now what's here? I want you to watch this. 8 factorial over 8 minus 5 is 3 factorial, and then 5 factorial. Well, hey, guess what? That's the same as this one, isn't it? Right? 3 factorial, 5 factorial, 5 factorial, 3 factorial. They're the same. And so this is going to be, and again, you can just go back. It's going to be symmetric. You can go back and just keep repeating the numbers. So the number on the other side is going to be the same. It's going to be a 56. Or you could figure it out if you want to waste time. 8, 7, 6 over 1, 2, 3. And again, you get 56. And the same pattern is going to keep on going through the rest of the way. So now that I just showed you that, we can quickly get our answer here. This is going to be x to the 8th. The next one, the first number coefficient is 1. The next one's always going to be whatever the power is, and that's going to be 8 because that's 8 things taken 1 at a time. And then that's x to the 7th and y to the 1st. We drop the exponent down by 1, and the y's are going to go up by 1. The next one is going to be 8 times 7. We've got 8 things taken 2 at a time, so there's going to be 2 numbers. 8 times 7 over 1 times 2, or 2 times 1. So 8 times 7 is 56, divided by 2 is 28. And that'll be x to the 6th, y to the 2nd. Now we're going to go 8, 7, 6, 3 numbers over 1, 2, 3. And that's going to be 56, because That's 3 times 2 is 6 is canceled, which we showed you on the last, a little bit ago. And so we got x now to the 5th, and then y to the 3rd. Now we're going to go 8, 7, 6, 5 over 1, 2, 3, 4. And that's going to, we already figured out on the last, a little bit ago, that that's 70. And that's x to the 4th, y to the 4th. Once again, once you get to the point where these are the same, we know we're just going to go backwards symmetrically. So we're going to go now with a 56, and it'll be x to the 3rd, y to the 5th. Again, exponents adding up to 8, and they keep going down by 1. The next one is going to be 28 as we continue to work backwards. Like this is 28 right here, so this has got to be 28. X to the 2nd, y to the 6th, and then we go, keep, the next one is 8. As we look back here, that's 8. So that's going to be x, y to the 7th. And then finally, it's just going to be 1 is the last coefficient, and it's just going to be y to the 8th. And that's the expansion of x plus y to the 8th. And so now let's take a look at some other questions they're going to ask us. It says, find the coefficient of x to the 10th in the expansion of x plus 2 to the 15th. And you're like going, whoa. And I remember I used to say that. What the heck? How do you do that? Does that mean I have to expand x plus 2 to the 15th? No, you do not. I want you to look at this example, and we're going to look at some patterns that develop here. Okay? So, when the x plus y to the 8th, I want you to notice that since we're talking about, we want the coefficient of x to the 10th, okay, we need to know about what term would be x to the 10th. Well, let's take a look at this one with x plus y to the 8th. Which term would be, let's say, x to the, I don't know, let's say x to the 6th. So which term is x to the 6th? Well, that's this one right here. I want you to notice the properties of the exponents and the combination numbers. All right, so if you notice, x to the 6th, y to the second, the coefficient is combination of 8 things taken 2 at a time. Do you notice that the exponent on the second part of the binomial, in this case y, the exponent is the same as the second number in your combination? Look, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, you get it? 6, 6, 7, 7, 8, 8. So that's always the same. And the first number, exponent, the first part of the binomial, the x, it is raised to the difference between these. So 8 minus 3 is 5. 8 minus 2 is 6. 8 minus 1 is 7. 8 minus 4 is 4. 8 minus 5 is 5. I'm sorry, 8 minus 5 is 3. 8 minus 6 is 2. So those are always the difference. So in x plus 2 to the 15th, if we want to find the term that has x to the 10th, then, okay, so we know we're going to have x to the 10th. What's this going to be the combination of? Well, we know it's to the 15th power, so it's going to be the combination of 15 things taken how many at a time? Well, we know that when we subtract, we said before, if we subtract the two numbers, it equals the exponent on the first term. So that's going to be 15 minus 1 equals 10. Well, that's 15 things taken 5 at a time. And then that means it'll be x to the 10th. And then the second term is a 2, so it'll be times 2 to what power? Well, remember we said that the exponent on the second term is the same as that second number in the combination, 3 and 3. So this number is a 5, so that means this exponent has to be a 5. And also another way to look at it is they have to add up to 15, so that number has to be a 5. So it's going to be 2 to the 5th. So this is the term that has x to the 10th. So now they want to know, well, what is that coefficient? Well, we haven't answered that question yet, because what we have is the combination of 15 things taken 5 at a time is going to be 15 factorial over 10 factorial, 5 factorial. But you don't really need to do that because what did I teach you? It's just going to be 15, 14, 13, 12, 11 over 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1. And if you're doing this by hand, obviously we would go 4 times 3 is 12 and get rid of that. And the 5 would go into the 15 3 times, and the 2 would go into the 14 7 times. So you'd have to take 3 times 7 times 13 times 11. And that comes out to be 3,003. But then you have to multiply that times 2 to the 5th to get the coefficient, because you would just write this. This is only going to have one letter in it, x to the 10th. The other term wasn't a letter, it was a number. So 2 to the 5th is 32. So 3,003 times 32 is going to be 96096. So that's 96,096 would be the coefficient of that term with x to the 10th. Wow, that's a big number. At this point, I think I should probably show you, I don't know, I can't remember if Mr. White did in the video or not, but show you how to use your calculator to do this, because obviously you had to use a calculator anyway, so you're probably not going to go through this process of canceling everything out and everything, but it's important for you to know how to do that, because if you don't have a calculator that has that function ability of NCR on it, you would have to know how to do that. But let's take a look at and make sure you know how to use your calculator. It does have an NCR button on it, and also has an NPR button on it. So let's take a look at that right now.
All right, so let's show you how you can use your calculator to do the calculation of a combination of 15 things taken 5 at a time. So where you're going to find that is it's under Math, and you will hit Math, and then you want to go to Probability, and you can see that you have you can calculate the permutations or combinations. We are doing combinations, so we're going to go to number 3 and put that in. And if you have the newer calculator, it'll just come in like this, and you go ahead and plug in your 15 and put in your 5, and you get your 3,003 that way. So if you have an older calculator that doesn't have this, the math print, you have to actually type in the 15 first, and then the NCR button, and then the 5. And you'll know if that happens, that's what you have to do. So if you get confused, if you have one of those older calculators, you have to do the 15 first, then you go in and hit the Math, Probability, and then the number 3, and then the 5, and then it'll still give you the right answer. So that's how you do this on your calculator.
So now we'll do the next one. We'll find the coefficient of x to the 12th, y to the 3rd, and x plus y to the 15th. So we're going to, again, have the combination of 15 things, and the letters are going to be x to the 12th, y to the 3rd, they told us. So what is this other number going to be? Well, we know it's going to be a 3 because this second number is a 3. And to find the coefficient, it's just going to be the combination of 15 things taken 3 at a time. Now, with this one, again, that's going to be 15, 14, 13 over 3, 2, 1, or 1, 2, 3. 2 goes into 14 7 times. 3 goes into 15 5 times. So it's 35 times 13. And that answer comes out to be 455. Again, you could have used the combination of 15 things taken 3 at a time on your calculator, like I just showed you how to do, and you could have got it that way as well. I just did it that way because it's probably just as quick. So number 4, what's the coefficient of x to the 6th, y to the 9th? Again, 15 things taken, and we have x to the 6th, y to the 9th, so that second number is going to be a 9. Now, we do that on our calculator, and you'll get 5,005. If you didn't have a calculator with that capability, then again, you would do the 15. Now, I want to show you something about this, 15, 14, 13, and you would think you have to go all the way down to 9, but you don't, because 15 minus 9 is 6. So 15 things taken 9 at a time is the same thing as 15 things taken 6 at a time. So we can just put down 6 numbers. So that'll take us down to 10. And then it'll be 1, 2, 3, 4, 5, 6, or 6, 5, 4, 3, 2, 1. Doesn't matter how you do it. I like to count up on the bottom. Just makes it nice and easy. And you could do all the canceling and everything, and you'll get 5,005. I'm not going to do that now. So now we have an interesting one. For the first time, we have a minus sign. So what happens then? Well, I will tell you that when you do a minus, every other term is going to be negative. It will start with positive and go positive, negative, positive, negative. So for this problem, we're going to have the combination of 13 things, and we're not sure. Okay, so this is going to be x to the 6th. So I'm not sure what this number is going to be at. Well, I do, but anyway, x to the 6th. And then it's going to be times, and you can, one of two ways to do this. It is a negative 2 to the what power? Well, we know the powers have to add up to 13, so that'll be to the 7th power. And then that means this is going to be 13 things taken 7 at a time. So you'll calculate the combination of 13 things taken 7 at a time, which comes out to be 1,716 times negative 2 to the 7th, and that comes out to be a negative 219,648. So the combination now of 15 things taken 6 at a time, if you calculate on a calculator, I think we'd already done that one other time, but anyway, it comes out to be 5,005. And that's going to represent the coefficient of which term of a binomial raised to what power. So how are we going to figure that out? Well, let's take again a look back at the patterns. This is all about patterns. So in this problem, when we had the combination of, let's say, 8 things taken 3 at a time, which term was that? Well, you know that the first one is a combination of 8 things 0 at a time. The second one, 8 things 1 at a time. And we go all the way down through here. So the number of the term, this is the first term, the second term, the third term. The number of the term is always one more than this second number here, isn't it? So the second number here is a 6. So that must mean that this is the 7th term of the binomial. And that 7th term of the binomial raised to the 15th power. So basically the first number tells you the power that the binomial is raised to. The second number is always going to be one less than the number of the term. So that's an important thing for you to know. So now we have a question that says, in the expansion of x plus y, or x minus 2y to the 8th, what is the second term? Second term's pretty easy. We could do that without knowing a whole lot, because we know the first term is x to the 8th, and we know the second term is going to be a minus, because it alternates plus minus, and I'm going to show you another reason why for that in a minute, but it's x to the 8th minus, and then it will be 8, because the coefficient of the second term is always the same as the exponent. And then it'll be x to the 7th, and then it will be 2y to the first. Now, since I knew it was negative, I put a 2y here, but the other way you can look at that is x plus 8x to the 7th, and then put a negative 2y to the first. And when that exponent is odd, right here, and you have a negative second term, then that's automatically going to make that second term negative, because an odd power, a negative to an odd power is going to be negative, and so it'll turn that into a negative. If you go ahead and put the negative in to start with, then you have to use a positive 2y here. So you'd have to pick which way you want to do it. It doesn't really matter. So the second term here is going to be the combination of 8 things taken one at a time. Remember, this number here, this 1 is always, this number is always 1 less than the number of the term. So that'll be then in this x here, the first exponent. The first exponent is always going to be the difference. 8 minus 1 is 7. And the second exponent, the negative 2y, the negative 2y, its exponent is always going to be what that second number is, that 1. So that'd be the first. So that's simply going to be 8x to the 7th times negative 2y to the first, which ends up being negative 16x to the 7th. Y is your second term. All right, now what about the 6th term? The 6th term will be the combination of 8 things taken 5 at a time. Remember, that number is 1 less than the number of term. And if you ever forget that, just remember it starts out with a combination of 8 things 0 at a time, and that's the first term, and you can see that 0 is 1 less than the first, than 1, the first term. So it's a combination of 8 things 5 at a time, and that will be 8x to the 8 minus 5 is 3, and then it'll be negative 2y to the 5th. Well, the 8 things 5 at a time is 8, 7, 6, and you could go 5, 4 to get 5 terms, but remember, 8 things 5 at a time is the same as 8 things 3 at a time, because 8 minus 5 is 3. So it's 8, 7, 6 over 1, 2, 3, and x to the 3rd, and then this will be negative 32y to the 5th, and that equals 56 x to the 3rd times negative 32y to the 5th. And my final answer is 56 times 32 is negative 1792, and it'll be x to the 3rd, y to the 5th. All right, so now let's look at the next one, which is the expansion of 3x minus y to the 17th. And they want to know the 8th term. So that's going to be the combination of 17 things taken what? Well, that'll be 7 at a time, 1 less than the number of the term. It'll be 3x raised to the 17 minus 7 is 10th power. And then it'll be a negative y raised to the 7th power. And if we do those calculations, you get negative 1,148,384,952 x to the 10th, y to the 7th. So what about the 6th term? And again, when you did that calculation, remember, you got a calculator, find the combination of 17, 7 at a time with your calculator, and then multiply it times 3 to the 10th, and that's what gives you that number. So for the 6th term, it's going to be the combination of 17 things taken 5 at a time. Remember, again, this number is 1 less than the number of the term. It'll be 3x to the 17 minus 5 is 12th power, and it'll be a negative y raised to the 5th power. And when all of that is calculated, you get negative 3,288,556,908 x to the 12th, y to the 5th. So now we're going to use the binomial theorem to expand x plus 2y to the 3rd. So x plus 2y to the 3rd will be, and if you don't necessarily have to write these out, it depends on whether I ask you to on a test or not, but we will do it just for the practice. It'll be the combination of 3 things 0 at a time, and then it'll be x to the 3rd, and it'll be 2y to the 0. This will be then the combination of 3 things 1 at a time, x to the 2nd, 2y to the 1st, combination of 3 things 2 at a time, x to the 1st, 2y to the 2nd, plus the combination of three things 3 at a time, x to the 0, 2y to the third. So again, you probably didn't have to write that step out unless I ask you to, but the bottom line is the first coefficient is going to be a 1, and it's going to be just simply x to the third. And then the next thing is we do have a 3 here. The combination of three things 1 at a time is 3 times 2, so that's going to be a 6, and it'll be x squared y. And then, and the thing you got to be careful with here is this is 3, and then you got to multiply it by that 2. You can't forget to multiply by the other number. So then we have the combination of three things 2 at a time, which is 3 times 2 over 2 times 1, which gives me 3, but I have to multiply by 2 squared, which is 4. So 4 times 3 gives me 12. And that'll be x to the first, y to the second. My last term will just have a coefficient of 1 here with the three things 3 at a time, but then it's times 2 cubed. So that'll be an 8y cubed. And that is the answer to number 9. So for number 10, I'm going to skip that first part with the combination numbers and all that, and we're just going to try to write it out. So we will start with, we know that we're just going to take the first term, 2x, and raise it to the 4th power. The coefficient is 1. The next term is going to be negative because it'll be negative 3y to the first, so that's going to make it negative. So I'm just going to go ahead and put the negative there now. And the coefficient, of course, will be 4. We know from Pascal's triangle that it's going to go 1, 4. We always know the coefficient of the second term is always the same as the exponent. So it's going to be 4, and it'll be times 2x to the 3rd power as we go down by 1, and then 3y will be to the 1st power. The next term will be positive, and the next coefficient will be 4 times 3 over 2 times 1, which is going to give me a 6, and it'll be 2x raised to the 2nd power and 3y to the 2nd power. Then it'll be a minus, and it'll be 4 times 3 times 2 over 1, 2, 3. And that'll be a 4 again. And I didn't really need to do that because you notice that we're going to have 5 terms. It's always one more than the exponent. And we also know that this has to be the middle term because the exponents are the same. So it had to, once you get to that exponent's the same, we know that the coefficient on the next term is going to be the same as the one before it. So that's going to be 4. It's going to be 2x to the first, and 3y is raised to the 3rd. And then finally, a plus, and the coefficient again is 1, and it'll be 2x to the 0, and it's just going to be 3y raised to the 4th. So then you just have to calculate 2 to the 4th is 16, so the first term is 16x to the 4th. Then you're going to have to take 2 cubed is 8, times 4 is 32, times 3 is 96, so it's going to be 96, and it'll be x to the 3rd y. The next one, we've got 2 squared is 4, 3 squared is 9, 9 times 4 is 36, 36 times 6 is 216, and it'll be x squared y squared. Now we have 3 cubed is 27 times 2 is 54 times 4 is also 216, xy to the 3rd. And finally, 3 to the 4th is 81, and y to the 4th. So I will now tell you that most students that I've had in the past aren't real thrilled with what I just taught them, but I think it's kind of cool. Most kids, if I ask them to expand x plus y to the 6th on a test, guess what they're going to do? They're going to go like this. They're going to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Notice they learn the pattern of Pascal's triangle. Okay? And I have to do this until I get to where the second number is the exponent, 6, and that's this one. So we've got 20, 15, 6, and 1. So I know that this is going to be, these are going to be the coefficients of x plus y to the 6th. And so now to write out my answer, all I have to do is say, okay, it's x to the 6th, and then plus 6, and it's x to the 5th y, and then 15, and then we go x to the 4th y squared, and then 20, x to the 3rd y to the 3rd, and then we go backwards. Again, it's symmetric. Once we know this is our middle term, and then it's going to be 15 again. It'll be x squared y to the 4th, and then 6xy to the 5th, and finally plus 1y to the 6th. And there we have it.